If 70.2 grams of carbonic acid are sealed in a 3-liter soda bottle at room temperature and decompose completely via the equation below, what would be the final pressure of carbon dioxide in atm, assuming it had a full 3-liter in which to expand? So this problem actually has two parts. The first part would be the stoichiometry, and the second part will be using the ideal gas equation. So let's do the first part first, stoichiometry. So in the problem, we are given 70.2 grams of carbonic acid, that's H2CO3. So since we are given grams, the first thing you need to do is to convert grams into moles. So from grams of H2CO3, you convert that to moles of H2CO3. So how do we convert grams into moles? We will use the molar mass of H2CO3. So 1 mole of H2CO3, that's equivalent to 62.026 grams of carbonic acid. Okay, so as you can see, the grams of H2CO3 will cancel out. Now you have moles of H2CO3. Then next, what you can do is to convert moles of H2CO3 into moles of CO2. So how do you do that? You simply look at the balanced chemical equation. So according to the balanced chemical equation, for every 1 mole of H2CO3, it produces 1 mole of CO2. So you put the mole ratio 1:1. Okay, so as you can see, the moles of H2CO3 cancels out. Now you have the moles of CO2. And then you can grab your calculator and solve for the moles of CO2. So that's 70.2 times 1 divided by 62.026 times 1 divided by 1. So from that, you will get approximately 1.13 moles of CO2. So now that you have the moles of CO2, we can now proceed to the second part of the solution, which is using the ideal gas law. So if you can recall, ideal gas law is PV equals nRT. And in the problem, it's asking us to solve for pressure. So in order to solve for pressure, you divide both sides of the equation by V, so that V cancels on the left side. So our equation becomes P is equal to nRT over V. So this is our equation to solve for the pressure. So all we have to do now is just to substitute the values. So P, pressure, is equal to N. N stands for the number of moles of the gas, which we solved in part 1. That's 1.13 moles times R is the gas constant, which you should memorize. It's not given in the problem, but it is assumed that students memorize the value of the gas constant, which is 0.0821 liter atmosphere per mole Kelvin. Okay, and then T is the temperature, which is in the problem, that's 298.15 Kelvin, divided by volume is 3.00 liters. So let's see how the units cancel out. The moles will cancel, the liters will cancel, the Kelvin would cancel. So the remaining unit is ATM, which is the unit for pressure. So our answer must be in ATM. So if you solve this in your calculator, so that's 1.13 times 0.0821 times 298.15 divided by 3, you will get approximately 9.2 22 atm. And this would be the answer to the question.